Now we will look at the power of a quotient. When we have a fraction inside parentheses, taken to an exponent, the exponent will be applied to both the numerator and the denominator. So it would just be like taking repeated multiplication of a fraction. This would be equal to 2/3 times 2/3 times 2/3 times 2/3. We can then, because we're multiplying, we can just extend the fraction bar and look at this as a series of repeated multiplication. 2 times 2 is 4, times 2 is 8, times 2 is 16, 3 times 3 is 9, times 3 is 27, times 3 is 81. So this expression, 2 to the 4th power divided by 3 to the 4th power, is the same thing as 2 divided by 3 to the 4th power. Likewise, when we have an expression without exponents in here with variables in both the numerator and denominator, the same thing applies. So this 3 is going to be attributed to every piece of that expression. So we would be looking at a to the 3rd times b to the 3rd divided by c to the 3rd. Now, since these bases are not common, they cannot be combined in any other way other than to remove the multiplication sign between them. When we move down to this third expression, there is considerably more going on. We have exponents, or variables with exponents that are taken to a power. We have coefficients that will be taken to that power. And we also have a fraction involved, so same thing that happens on the top will happen in the bottom, or the denominator of this fraction. So to start out, again, we're going to apply the exponent to every piece of the expression. So we would take the coefficient 3 to the 3rd power times x squared to the 3rd power times y to the 4th to the 3rd power. We would be dividing that by -2 to the 3rd power. Note how I put these coefficients in parentheses, especially this one because there was a negative involved, times z to the 3rd power. You might also note that when I write my z's, I put a horizontal line through them to make them look differently than my 2's, because my 2's and my z's often look the same. Now I would just go about evaluating this expression. I really have 3 times 3 times 3 times x squared to the 3rd power. If I really wanted to write it out, I could write x squared a total of 3 times, and I could do the same thing with y to the 4th power. My denominator, same thing. I'm going to keep this in parentheses because it is a negative number. And now with the variable, I'm going to do the same thing, just z times z times z. Now I would go through and simplify. Finally, 3 times 3 is 9, times 3 is 27. And I'm going to handle my other coefficient first. -2 times -2 is +4. +4 times -2 is -8. 27 and -8 do not have any common factors, so the coefficients are simplified. This should have been a 2 here. Hopefully you picked up on that error. I knew that these all needed to be the same because my factor needs to be repeated, so that's how I picked that up just now. I have 2 factors of x, another 2 factors of x is 4, and then a third 2 factors of x would be x to the 6th power. I have 4 factors of y, another 4 would be 8, and then another 4 would be 12, so this is going to be y to the 12th. And I still have my 3 factors of z in the denominator.